My name is Andrew Johnson. I will be presenting building construction and firefighter safety. Understanding building construction is essential for firefighters because the building itself can become one of the greatest hazards during a fire. The material used, how those materials are assembled, and the age and condition of the building all influence how fire spread and how long the structure can remain stable. A firefighter who recognizes a construction type can better anticipate where fire may travel, what areas may contain concealed fire, and which structural components could fail. Fire behavior and building construction work together. For example, a fire involving lightweight wood construction can spread and cause structural failure much faster than fire involving properly protected structural concrete or heavy timber. The 5 types of building construction are based primarily on the materials used and how those materials perform when exposed to fire. As we see in this slide, type 1 is fire resistive and commonly uses protected steel and concrete. Type 2 is non-combustible and commonly uses steel or concrete, but may have less fire protection. Type 3, or ordinary construction, typically has masonry exterior walls with combustible interior components. This type is most common with newer construction homes in our area. Type 4 is heavy timber construction and uses large wood structural members. Type 5 is wood frame construction and is commonly found in residential buildings. This type is typically in our older homes found inland from our community. You can also have a variation of any one of these types combined together. Type 3 with a type 5 is found in 2-story residential homes in our areas. Type 3 on the first floor and type 5 on the second floor. Knowing these 5 types gives firefighters a starting point for predicting fire behavior and structural hazards. Type 1 construction is designed to provide a high level of fire resistance. Reinforced concrete and protected steel can maintain their structural integrity for significant periods of time. However, firefighters still need to be concerned about the contents of the building, which can create tremendous heat and smoke. The Brittany is an example of one of those. Type 2 construction also uses non-combustible materials, but the major concern is often unprotected steel. Steel does not burn, but it loses strength as it becomes heated. During a prolonged fire, beams and columns and roof assemblies can deform or fail. These buildings would generally be considered modern construction, although the exact age depends on the individual building. Publix is a good example. On the slide on the interior, you can see exposed metal beam going up to the roof and exposed metal I-joist in roof structures. Type 3 construction is commonly called ordinary construction. It typically has masonry exterior walls, but combustible wood floors, roofs, and interior walls. Fire can spread through concealed spaces, making these buildings particularly important during size-up. Naples Depot is an example. Type 4 is heavy timber. A large wood member can perform better than lightweight wood because they develop a layer of charring when exposed to fire. However, they remain combustible and can eventually lose enough material to compromise structural integrity. We don't have any of these. We have faux beams in our community. Type 5 is wood frame construction. It is common in residential buildings and can be either traditional dimensional lumber or modern lightweight engineered construction. Lightweight components can fail rapid when exposed to fire. These homes are typically found in Golden Gate. Proper building design, installation, inspection, and maintenance are crucial to fire safety. Fire-rated walls and doors keep a fire contained to one area and provide additional time for occupants to escape. Maintenance is just as important as it is. Sorry, maintenance is as important as the original design. A damaged floor can be removed. A damaged fire door, removed fire stopping, blocking, sprinkler heads, or unauthorized renovations can compromise the building's fire protection. Fire does not affect every building the same way. Construction materials determines how quickly fire can spread and how long structural components can withstand heat. Type 1 typically provides the greatest structural resistance, but prolonged fire can eventually compromise components. Type 2 has a significant concern with heated steel. Type 3 can allow fire to travel through concealed wood space. Type 4 contains large combustible structural members. Type 5 can experience rapid fire spread and structural failure. Firefighters need to continuously evaluate construction type along with fire conditions rather than assuming the building will remain structurally stable. Some structural components are especially dangerous during a fire. Lightweight wood trusses and I-joists are common examples because they are smaller or engineered components. They can lose their structural integrity quickly when exposed to fire, 5 to 10 minutes. Lightweight steel can also weaken when exposed to high temperatures. Open web steel joists allow heat and fire to travel through the assembly and can eventually fail. Roof assemblies are particularly concerning because firefighters may be operating underneath or on top of them while the fire is weakening the structure. A building can look stable from the outside while the roof or floor system has already been severely compromised. For example, a church with lightweight wood roof trusses could present a significant collapse hazard during a fire. Knowing the construction before the incident allows firefighters to recognize the risks during the pre-incident planning and size up. Here are some of the examples. Inclusion and takeaway. Here are some of this is what's it's going to look like. Type 1 are high rises. Type 2 are mid rises. Type 3 is storefronts and homes. Type 4 we don't have in our area, and type 5 is full wood frame construction. In conclusion, understanding the building construction is an essential part of being a safe and effective firefighter. Construction type affects fire spread, heat resistance, structural stability, and collapse potential. The firefighter needs to recognize the 5 construction types, understanding how fire affects each one and identifies structural components that may fail during a fire. We also need to recognize the importance of fire rated assemblies, sprinklers, fire resistive coatings, and smoke control systems. Most importantly, this knowledge should be applied before and during an incident. During pre-incident planning, firefighters can identify construction features and potential hazards before emergency occurs. During size up, that information can help determine the safest tactical approach. Knowing how a building is constructed helps us understand how it may behave when it is on fire. The knowledge can ultimately save us in the fires. Here are my references. Did we learn something today? This is the open-end questions.
Excellent.
Very good, Andrew.
All right.
Learned a lot.
All right. Thank you very much. That will conclude today's lesson.